Hello, welcome back to another video. Today we're looking at the option type again in Rust. I say again because we've already talked about them a little bit in the error handling video, but there might still be some bits and pieces that we want to explore here. So let's have a look. Okay, I've already executed rustlinks watch in the rustlinks repository, and we see here that there's a compilation error in exercises options option 1.rs. And here we see that the compiler complains in line 12 that it expected an enum option but found an integer. And the same thing seems to be happening in line 13, and then there is some other errors down here that we'll take a look at right now. So let me open up exercises option and then option 1.rs. Okay, so here we see we have a function print number, and the code says you can modify anything except for this function's signature. Okay, so print number takes a number. It says it's maybe a number. It might be a number, maybe not. And that's why it is an option. Remember, if you've seen the other video about error handling, an option type represents the possibility of a value. So it may or may not exist. And that's why we also see here that when we try to print the given value, which may or may not be a number, we have to unwrap it. Because printing an option doesn't work, we have to access the actual value that the option wraps. And to get that, we have to unwrap it. I think it's important to note here, though, that when you deal with a value that is an option type, and there is the possibility that there is no value in that option, then it will give us a value of type none. Unwrapping such a value, which unwraps to none, will actually make the program panic. So that's something to always keep in mind. Okay, in this particular case, however, we always expect print number to be called with a value that does resolve to some actual value. And down here we see a print number is called with 13 and 99. Here we already see this is an issue because we're passing down numbers. However, the function expects an option. So whatever we pass down here has to be either something of type sum and some type t, or something of type none. These are the two values that represent an option of type t. Okay, so to make these two lines work, we have to wrap this in sum here, and we have to do the same down here. Okay, and then we see we have a bunch of numbers. Numbers are annotated as an array of 5 options. However, it looks like they're not initialized with an actual value. So let's fix that. We have to initialize them because when something is annotated of type option, it still needs to have an initial value because the option itself is just an enum. So we have to assign an enum variant, right? So here we say that this is an array of, we could say, okay, we initialize all of these numbers, 5 of them, with none, like this. And if you've seen the other video about arrays and vectors or collections, then you know that we can make this much shorter by just saying, okay, we create an array with the value none, in fact, with 5 of those. And then these are initialized properly. Okay, and then we iterate over some numbers and we create a number here, and then we want to assign whatever number is created down here to our numbers array. Now in this case, we have to make sure again that the number to add is wrapped in an option, because we know numbers is an array of option of U16. So just assigning a number here won't do the trick. We have to wrap it in sum. Let's save this and see what the compiler says. Oh, there's a missing semicolon. Classic, right? Okay, saving this one and checking again. Okay, cool. This is compiling. Off to the next one. I'm gonna remove the comment here. Okay, and then we have another compilation error in options 2.rs. There seems to be some syntax error there. So let's open up that file, option 2.rs. Okay, there's no additional description here. So let's see what's going on. We have an optional value of some string. And then there's a comment that says, make this an if-let statement whose value is of some type. Okay, so this is pretty cool. In Rust, there is a construct called if-let, which you can use to unwrap an option to access the wrap value in case the option does hold a value. So for example, here we see that we do something with the optional value. This is where we have to use the if-let syntax. And if the option does indeed hold a value, so if it's of type sum, then we want to print this here. If not, we want to print the optional value doesn't contain anything. Obviously, there's multiple ways to go about it. We could either say something like match and then optional value. And then we could say, okay, if the optional value is of type sum and then some value, we want to say print and then, print the text and then pass the value here. And if it's none, then we want to print, some other text. Another way to do this here is to use the if let syntax, if let, and then some value equals to optional value. So this is gonna give you a little peek into that option without unwrapping it here. We execute this branch, otherwise we execute that branch. And the cool thing is the same thing works with result types as well. So we could say if let okay, some value in case this was some error, or rather some result. And then you can react to a result and kind of ignoring the error case, if you will. Okay, but we don't want to do that here. Let's change that back. And then down here, we see we have a vector of optional values, vector of option of I8. And then we create the vector here, and then we iterate over some numbers, and then we just push some values into that vector. And then here we see there's a comment that says, make this a while let statement. Remember that vector.pop also adds another layer of option T. You can stack option T's into while let and if let. Okay, so what this means is we should be using while let and then some value here. And then as long as we do get a value, you want to print it. Now the catch here is that the pop function of a vector already returns an option value. It doesn't actually pop off the concrete value, it pops off an option because maybe there is no value to pop off the vector, in which case it would be a value of type none. So simply saying while let some value is not going to do it because the value here is still going to be an option. Now there's a couple of ways to go about this. We could go ahead and say, okay, we just always expect the value that we get to always resolve to some value, so we can simply unwrap it. However, as I've said earlier, if value does unwrap to none, the program is going to panic and fail. And this is still a possibility here if the vector turns out to be empty. So we cannot do that really. However, what we can do is we can, as the comment says here, stack the option type. So we can say sum of some value. And this is how you unwrap an option that's wrapped in an option. Okay, saving that and see what the compiler says. Yay, this is compiling. Wonderful. Okay, removing the comment and moving on to the next one. And that was already it, a quick session about options. I think it's good to know the if let and while let syntax, and also knowing that you can stack option T types. Hopefully this was useful to you, and thanks for tuning in.